In 12.2, we learned how to multiply and divide rational expressions. In 12.3, we'll be adding and subtracting rational expressions. Fractions are a bit unique in that multiplying and dividing is actually easier than adding and subtracting. So let's just review. How do we add 1/2 plus 1/3? So, hopefully we know that this is the wrong way, but let me put it out there. We cannot just add the tops and add the bottoms. That does not work. Visually, what this means is that it's half a circle plus 1/3 of a circle, which would be like this. But we need a common denominator, right? That's not the same as just 2/5, which is 2/5 is actually less than a half, weirdly, right? So it definitely doesn't work. So instead, we need to make them both out of 6. So we multiply this first fraction by 3 on top and bottom, because 3 out of 6 is the same as 1/2. And this one we would multiply by 2 on top and bottom. 2 out of 6 is the same as 1/3. And then once the denominators match, we add the tops but keep the same denominator. So that's the process. And 5 out of 6 means we filled up almost the whole circle, right? If I add a half plus a third, we filled up most of the circle, not something that's less than a half. All right, well, let's do some of these. Just make sure we have to get a common denominator. We did not even mention common denominators when we are multiplying and dividing. It's only for adding and subtracting that you need that common denominator. All right, so let's do some. 6 over 5 plus 2 over 5. Hey, look, the denominators match. So all we do is add the tops, keep the same denominator. Now, you could make this into a mixed number, but there's no reason to. And actually, in algebra, improper fractions are preferred. So I'm just going to leave it as 8/5. Done. All right, well, now we know fractions can have x in them. They're called rational expressions, but as long as the denominators match, the rule is the same. I add the tops, 9 plus 3 is 12, and keep the same denominator. And that's it. Subtraction works the exact same. You have to make sure you have the same denominator, and once you do, that denominator stays the same, and then we just subtract the tops. 23 minus 20 is 3. Oh wait, this one does have another step. We should still be reducing our fractions. So reducing our fractions means factoring if it's a rational expression, or in this case, we can just divide both the top and bottom by 3. So for this one, the fully simplified version is 1/7. Okay. Now, subtraction does get a little more complicated with rational functions in that this subtraction needs to distribute to both pieces in the top of the fraction. Or if there's 3 terms in the numerator, it needs to distribute to all 3 terms. It is very easy to forget that. So we're gonna, practice, remind yourself, oh yeah, that subtraction applies to everything in the top. I'm not gonna put the subtraction with the denominator generally. We just distribute it to the top. So numerator, we're going to write out, I'm writing this one out, 6x minus 7, then minus 4x minus 3, because negative distributes to both pieces in that second numerator. The denominator, though, it matched, so it just stays x minus 5. And now we simplify by combining like terms in the numerator. 6x minus 4x is 2x, negative 7 and negative 3 make negative 10, and the bottom's x minus 5. Ooh, I don't think this is simplified yet, because we can factor out a greatest common factor here. there's a 2 in this numerator, and then we get x minus 5 over x minus 5. Ooh, they threw a hard one at us right away. So if the x minus 5's cancel, we're equal to just 2 with the added restriction that x cannot equal 5. Just like that last section, after you reduce a fraction, we have to make sure that we're not dividing by 0. So x equals 5 would have been a divided by 0 in the original problem and right here. We didn't have to do that in this reducing of the fraction because we only divided by 3. 3 can't be equal to 0, right? So this was like 3 times 1 over 3 times 7. I did cancel the 3's, but there's no x here, so it can't be 0. So that's why I didn't need an x can't be a number on this one. Okay, let's do some examples where we don't start out with the same denominator and we have to get common denominators. In this case, let's see what the directions say. We need to build each fraction to the least common denominator in the same way we do with numerical fractions. And that is to multiply the top and the bottom by the same thing. Multiply top and bottom. All right, so let's do that. So here in part A, the common denominator that we need to make is 14, because 7 times 2 is 14. That's the least common denominator. And if it helps, like write that out, LCD equals 14. Now we need to figure out what do we need to multiply by to make the 7 into 14. Well, I gotta multiply by 2. So that means I also have to multiply the top by 2. So 6 out of 14 is the same as 3 over 7, just not reduced. Let's do the same thing for the second fraction. The 2 needs to be multiplied by 7, so I have to do the same on the top. 5 times 7 is 35. Now that we have the common denominator, we can keep that 14 on the bottom and add the tops. So it'd be 41 out of 14. And you would probably want to check that to see if that reduces, but the only things that go into 14 are 2 times 7, and I don't think either of those go into 41. So that is it for that one. All right, let's do these with some x's involved. So we need to find the least common denominator. For the LCD, we need to first find the LCD of the numbers. In this case, 2 times 3 makes 6. And then as far as the exponent or the variable goes, both of them have an x, so we need to make both of them be 6x. See how if we multiplied this first fraction by 3 and the second fraction by 2, that would make them both 6x in the bottom. That's why that's the least common denominator. Okay, well now we just need to do the same thing for the tops. That means the first fraction we multiply by 3, so it's 12 out of 6x. And the second fraction we're multiplying by 2, so that's 18 out of 6x. So when I add them, it looks like 30 divided by 6x. And I need to reduce this. If I divide the top and the bottom by 6, that would be 5 over x. Now, what I reduce by doesn't have an x in it, so we don't need any additional like domain restrictions like we did up here, because we're only factoring or reducing by a number, not an x. Okay. Part C. First step is to find a common denominator. Things are looking a little different. First step is to factor. So I need to think of 3x minus 9 as 3 parentheses x minus 3, right? Multiply it out, that's the same denominator, but in factored form, hopefully that's like, oh yeah, we just need to multiply this first fraction by 3 on top and bottom, and then both fractions would have that same denominator. The least common denominator in this problem is 3 times x minus 3. And I'm going to keep my denominators factored. So I want it in that form. Okay, so what this is going to look like. The denominator is going to be 3 times x minus 3. And the first fraction, once I multiply by 3, the top's going to be 6. And hopefully we can see, like, oh yeah, 6 divided by 3 is 2. So this is the same as 2 over x minus 3. It's just not reduced because we built it to have that same denominator as the other fraction. And I'm also going to write that denominator factored. And then 11's on top. So our answer is going to have that same denominator, 3 times x minus 3. And then we just need to do 6 minus 11 is negative 5. We didn't cancel any factors, so we don't need domain restrictions. All right, same as this last one. When we have binomials or eventually trinomials in the denominator, we got to factor them. We didn't do that here because they were already factored. There was no pluses or minuses in the denominator. But now there are. So first one is difference of two squares, x minus 9, x plus 9. The second denominator has a GCF of 2, and then would factor as x plus 9. We see how those would be the denominators factored. I'm not actually worried about factoring numerators at all. Here we don't have any numerators to factor, but even if we did, I wouldn't bother factoring them. I'm only worried about finding that common denominator. So in this case, the least common denominator is going to have a 2, and then it needs an x minus 9 and an x plus 9. So it needs all the pieces that are represented, but only one time. All right, well, what that means is the first fraction is missing this 2. So I need to multiply 2 by the top and the bottom. 27 times 2 is 54, and then the bottom is 2 times x minus 9 times x plus 9. I'm leaving that denominator factored. Plus, all right, now we look, and what's missing from this LCD is the x minus 9. So that's what I gotta multiply by, x minus 9 on top and bottom. That's how to get that denominator we need. 2 times x minus 9 times x plus 9. I can multiply the factors in either order, but that means the top involves distribution. I gotta multiply that out. 3x minus 27. All right, it's definitely getting more complicated. We know the denominator is that common denominator, and I'm leaving it factored. Don't multiply it out, no reason to. Leave denominators factored. But I did multiply out the numerator, and that's because now we need to combine like terms. I know I got a 3x. 54 minus 27 is 27. Ooh, and we are not done yet because there's a greatest common factor of 3 in the top. So 3 times x plus 9 is what you'd get if you divided by 3. And then the bottom is the same, 2 times x minus 9 times x plus 9. But an x plus 9 cancels. So final answer is 3 over 2 times x minus 9. Again, leave the bottom factored. But we have that additional restriction that x cannot equal negative 9. Because that would make this term that we, or factor, not term, factor that we canceled equals 0. Or in other words, it would make the original problem divide by 0, which is not allowed.